Numericals. If the focal length of a magnifying glass is 10 centimeter, that is focal length is equal to 10 centimeter. Find the magnification of this simple microscope for relaxed and strained eye. It means the least distance of distinct vision is equal to 25 centimeter. Or we can say least distance of distinct vision. So for relaxed eye, for relaxed eye means the image is formed at infinity. Image is formed at infinity. So magnification when the image is formed at infinity, that is for relaxed eye, is equal to d by f. Second case, for strained eye. For strained eye, the image is formed at least distance of distinct vision. So magnification for strained eye when the image is formed at d is equal to 1 plus d by focal length, and therefore m d is equal to 1 plus d by f is equal to 1 plus d by f is equal to magnification at infinity, or we can say magnification at least distance of distinct vision is greater, that is magnification and least distance of distinct vision is greater than magnification at infinity. So the magnification lies between magnification of relaxed eye to magnification when the image is formed at least distance of distinct vision. So first case is relaxed eye. Relaxed eye. For relaxed eye, magnification relaxed eye is equal to d by f, where d is equal to 25 centimeter divided by focal length 5 centimeter. Therefore, m at infinity is equal to 2.5. That is, h of height of image by height of object is equal to magnification is equal to 2.5 for simple microscope. Or we can say height of image is equal to 2.5 times of height of object. Second case, for strained eye. For strained eye, magnification, the image is produced at the least distance of the distinct vision, which is equal to 1 plus d by f is equal to 1 plus d by f. D by f is equal to magnification produced by strained eye, m infinity. So m d is equal to 1 plus m by m infinity is equal to 2.5 is equal to 3.5. Therefore, height of image by height of object is equal to 3.5 is equal. Therefore, height of image is equal to 3.5 times of height of object. Therefore, magnification at least distance of distinct vision is 3.5, and when it is formed by relaxed eye, when the image is formed at infinity, is equal to 2.5. Therefore, m of d is greater than m at infinity. This is strained eye and this is relaxed eye. Image is formed at least distance of distinct vision, image is formed at infinity. That is 3.5 can see 3.5 is greater than 2.5. A thin convex lens of focal length 5 cm is used as magnifying glass for a person with normal near point. The person is with normal near point. Find the closest and farthest distance at which he can read the book when seeing through the glass. First, calculate the ratio of maximum and minimum angular magnification. First, we have to find this is a normal person. So, this is the lens. This is a person seeing through his eyes. And the images, that is, first image V, thin convex lens, focal length. So focal length is equal to 5 centimeter, and it is positive because it is convex lens. The closest distance which a person can read the book is 25 centimeter, because the person with the normal near point. So that is D, least distance of distinction. Here it is find the closest and farthest distance at which he can read the books seeing through the glass. So for closest distance, the image is formed. The image is formed at a distance of distinction, that is 25 centimeter. It is negative because this is ray direction. So image is formed. So he is to read the image at 25 centimeter, which is also distance of distinction for the person. Okay, then focal length is given 5 centimeter. Now we have to find out U minimum. Minimum U we have to find out. It means at 25 he has to see where he has to that object to be kept. The point, find the closest. The book, where the book is supposed to keep. The book is the object where it is supposed to be kept, so that he can see it at the least distance of distinction. It means the image to be formed at V. So we can calculate 1 by V minus 1 by U is equal to 1 by F. In this we can write it, since we want U, you keep U here. 1 by U is equal to, that side, 1 by V minus F will come 1 by F. So here U is the minimum distance at which minimum U, when if it is this image is to be formed as least distance of distinction, the image distance should be minimum. U minimum, U is equal to U minimum is equal to 1 by V is equal to V is equal to the person near point, that is V is equal to 25 minus 25 minus 1 by focal length is plus 5. So this is equal to minus of 1 by 25 plus 1 by 5. So 1 by U minimum, where the book is supposed to be kept as an object, is equal to minus, you take the 25 as LCM, 25 means 1 plus 5. So it's equal to minus 6 by 25. So U minimum is equal to minus 25 by 6. Centimeter, it's supposed to be centimeter, which is equal to minus 4.16 centimeter. 4.16 centimeter. Now, the farthest point, the farthest distance which the person can read. The fastest distance a person can read the book. The book is at infinity, because minimum distance is that book should be kept so that the image is formed as least distance of distinction. The farthest distance the image to be formed at infinity, so then he can read the book, which maximum object distance is infinity, that is far point. This is near point, far point, that is far point. Therefore, the image to be at infinity, that is v is equal to minus infinity. When v is equal to minus infinity, putting this thing in its formula, 1 by u maximum, since the image is formed at infinity, the object distance will be the maximum distance. U maximum is equal to 1 by v minus 1 by f. So 1 by u max is equal to 1 by v. V is minus infinity minus 1 by 5. 1 by infinity is equal to 0. Therefore, u max is equal to minus 5 centimeter. This minus indicate it is kept, the eye is here, the ray direction this way, the book is kept in front of the mirror, that's why the minus indicate minus 4.6. It means from the convex lens, 4.16 centimeter, it should be kept this side. Here also 5 centimeter, this side, u max. Now, so find the distance, he can read the book when seeing through the, so this is the distance, object distance up to which, that is, we can say 5 centimeter from the book. This is equal to 4.16 centimeter. Okay. Now, angular, next is calculate the ratio of maximum minimum angular magnification. The angular magnification is equal to, angular magnification is equal to distance of distinction, this general formula by object distance. So angular magnification will be maximum if u is minimum. Angular magnification will be maximum if u is minimum. Maximum means this should be minimum, this should be minimum means this should be maximum. So maximum angular magnification is equal to d by, this is for maximum, it means it should be u minimum, because both are inversely related. So which is equal to 25, u is minus 25. You can take it with sign convention also. U minimum, where is u minimum? Divided by minus 25 divided by 6. Minus minus cancels, 25 cancels, 6. So since the ratio of distance, so it has got no unit. Minimum angular magnification. Angular magnification is equal to d by, if this is minimum, u has to be maximum. Is equal to minus 25 by minus 5 is equal to 6. It's asking calculate the ratio of maximum minimum angular magnification. Maximum angular magnification divided by minimum angular magnification is equal to, maximum is equal to 6 divided by 5, which is equal to 1.2.